What is going on, Cyber Warriors? Jason Shong back with another video, and today we are on TryHackMe's Advent of Cyber 2025 Day 6. The lab that we're going through today is called Malware Analysis Egg-xecutable. The description says we're going to be discovering some common tooling for malware analysis within a sandbox environment. And as always, TryHackMe has two wonderful cyber professionals that are available to give walkthroughs for you in this lab. They have TryHackMe themselves, actually, a member of TryHackMe's staff. And then we also have Gwendolyn, who I will not try to butcher her last name, but this video was also amazing as well. Please tune in if you guys get the chance, and let's get to it. The town of Wareville remains quiet in the middle of the night. While the residents of Wareville are nicely tucked up in bed, blissfully unaware, the SOC team at the Best Festival Company remain alert, poised and ready for whatever may face them. Monitoring their screens, armed with freshly poured mug of hot cocoa, the elves of the SOC watch their dashboards diligently. Suddenly, the elves receive an email in unison from Elf McClaws, head of Elf Affairs, in their inboxes, and it reads, "All elves, going forward, we will be using a new program for creating and viewing team rotas. This new program will revolutionize how rotas are made here at the Best Festival Company. Please contact IT support if you have issues running the program. Kind regards, remain the best. Elf McClaws, head of Elf Affairs." And right here in the header, we have the attachments, and then you see that they sent a hop helper executable. So why is Elf McClaws working at 8 a.m.? Screams a member of the SOC team in the background. I do the same thing. They're right. Something is amiss. Elf McBlue is immediately suspicious. Their years of experience in the SOC have given them the wisdom not to download out of the blue executables. That's smart. Without McSkitty's wisdom, Elf McBlue takes charge. Loading up their malware investigation toolkit, the investigation begins. The learn objectives for this room are as follows. Today's room will have you taking the place of Elf McBlue, a highly talented member of the Best Festival Company's malware investigation squad. You've been tasked with investigating a highly suspicious executable that is being shared within the company. Today's room, we will be covering the following: the principles of malware analysis, an introduction to sandboxes, static versus dynamic analysis, and the tools of the trade, PeStudio, ProcMon, and RegShot. Have instructions to turn on the machines. So make sure you get your machines booted. I will open this in another window, and I'll see you guys on the other side. So now that we have our machine started, let's start up task 2. So principles of malware analysis. Malware analysis is the process of examining a malicious file to understand functionality, operation, and methods for defense against it. By analyzing a malicious file or application, we can see exactly how it operates, and therefore we know how to prevent it. For example, could the malicious file communicate with an attacker's server? If so, we can block the server. Could the malicious file leave traces on the machine? We can use these to determine if the malware has ever infected another device. Instead of fearing malware, we can take a proactive approach by translating technical findings into practical defensive measures, understanding how the malware fits into the attacker's techniques. There are two main branches of malware analysis: static and dynamic. Static analysis focuses on inspecting a file without executing it, whereas dynamic analysis is when you're going to execute the file. We'll come to these shortly. So this section is just giving us a rundown about sandboxes. In cybersecurity, sandboxes are used to execute potentially dangerous code. We use sandboxes in safe, isolated environments because if we're going to run malicious applications, malicious code, we don't want to risk exposing sensitive data or impacting other systems. The use of sandboxes is part of the golden rule in malware analysis. Never run dangerous applications on devices you care about. Okay? And most of the time, sandboxes present themselves as virtual machines. Virtual machines are a popular choice for sandboxing because you can control how the system operates and the benefit from features such as snapshotting, which allows you to create and restore the machine to various stages of its status. So basically, if you take a snapshot of a machine, you're taking its current configuration, and then if you make changes later on, or if you run malware that destroys your system, you can always revert back to the initial snapshot that you took. To reiterate, it is imperative to understand that potentially malicious code and applications should only be run in a safe, isolated environment. From now on, this room will refer to malicious code and applications as samples. With these fundamentals covered, let's move on to the practical section of today's room. The following will demonstrate a sample. You must apply these techniques to the hophelper.exe file presented to you within the hophelper folder on the desktop of the practical VM. That was like a tongue twist. Hophelper folder. Interactive static analysis. As we alluded to previously in the room, we use static analysis to gather information about a sample without executing it and digging deep. Static analysis can be a quick and effective way to understand how the sample may operate, as well as how it can be identified. Some of the information that can be gathered from static analysis has been included in the table below. We have 3 columns: information, explanation, and example. The first is checksums. So these checksums are used within cybersecurity to track and catalog files and executables. For example, you can Google the checksum to see if this has been identified before. So these are hashes. The checksums are like hashes, like SHA-256, and they act basically as like unique fingerprints for files. They let you verify the integrity of the sample or of the file of the malware and check if it's already known in threat intel database, such as VirusTotal. Second are strings. Strings are sequences of readable characters within an executable. This could be, for example, IP addresses, URLs, commands, or even passwords. So sometimes within malware, strings can give away what the malware is trying to do. The next thing we're going to look at is imports. Imports are a list of libraries and functions that the application depends on. For example, rather than building everything from scratch, applications will use operating system functions and libraries to interact with the OS, the operating system. These are useful, especially in Windows, as they allow you to see how the application interacts with the system. And then last but not least is resources. Resources contain data such as the icon that is displayed to the user, and this is useful to examine, especially since malware might use a Word document icon to trick the user. Additionally, malware itself has been known to hide in this section. However, it's important to note that regardless of how a sample may appear or function, we don't truly know until it's executed. Hackers use techniques such as obfuscation to obscure how the sample appears, primarily to evade antiviruses, but also to evade a curious analyst. So when we say we don't know what a sample does until we execute it, this is what we mean. Obfuscation is basically hiding the real behavior of a program. Instead of letting the code or like the strings sit in plain English, attackers try to scramble or like mask them so the file looks harmless on the surface. They do this for 2 reasons. So antiviruses, they usually recognize patterns, they recognize certain strings, functions, or known signatures. So if the attacker hides this, then the antivirus might not catch it. And the second thing is it also slows down or misleads analysts like us, because if we open an obfuscated file, the strings or imports could look completely normal, giving us like a false sense of security. But then it's actually malware that's hidden inside. So even if an executable looks clean during static analysis, it could be hiding real malicious behavior, and you don't know this until you actually run it. So that's why dynamic analysis, watching what the file does when you execute it, is so important in malware analysis. Let's get back to the lab. So demonstrating PeStudio. This section of the room will demonstrate using PeStudio on an example called downloader.exe. Please note that the information you see will be from this demonstration sample. The sample you will be analyzing will be different. Techniques still apply. And please note that it is imperative that you do not launch hophelper.exe. So we're going to launch PeStudio, load the executable into PeStudio, click on the indicators tab in the dropdown, then look for the SHA-256. Let's open PeStudio. Right here we have our hophelper folder, so let's open that up. Then you can drag and drop the hophelper executable into. And right here we see properties column, the file SHA-256. The first thing that we're going to want to do is check the hash, because this value is basically the file's fingerprint. It's how you verify like the integrity of an executable, and this ties us right back to the CI triad, specifically the second pillar, which is integrity. So even if a single byte is changed within this file, anywhere within the file, the entire hash would change. That's the beauty of hashing, and that's why it helps us in cybersecurity so much. Because if a file is modified in any way, shape, or form, it is going to tell us, because the hash is going to be different. And it also lets us search like threat intel platforms such as VirusTotal to see if this exact sample or this malware has been ever seen before. So they said that they wanted the SHA-256 value, which is this right here. We're going to copy the value and then paste it into our flag. Awesome. And for the next flag, it says, next we will proceed with reviewing the strings of the executable. You can do this by clicking on the strings indicator on the left pane of PeStudio. In the context of malware analysis, strings are the sequences of readable characters present within an executable. This could be, for example, IP addresses, URLs, commands, or even passwords. Now proceed to review the strings on the sample HopHelper.exe provided to you on the analyst machine on question 2. So if you go down to where you're supposed to submit the flag, it'll tell you right here, it gives you a little hint. It says that this can be found towards the bottom of the strings output. So we're going to go to strings on the left side. So once you open the string section, you'll see that the first line, it's actually like in readable text. This is just because most executable files within Windows, they have this DOS stub, which basically says this program cannot be run in DOS mode. Got it. But then under that, you see a bunch of random text. You might think that it's like encoded text or something, but this basically is showing us that PeStudio just pulls anything that resembles text out of the executable. So a Windows program is built with many different sections like .text, .data, and these sections contain like code, metadata, variables, and like raw bytes. But sometimes those bytes happen to form ASCII characters, ASCII, even though they were never really meant to be read by humans. So what you're saying right here is basically just artifacts or like binary data that just looks like text. It's unimportant. But what we will be looking for that is important is some of the strings that we see down here. You see, this is like actually real text. Then if we scroll a little bit down, it's giving us our flag right here. Try hack me strings underscore found. So let's copy this value and then paste that. And then move on to our next section. Interactive, dynamic analysis. This section of the room provides a brief introduction to dynamic analysis. As you recall, dynamic analysis involves executing the malicious sample to identify its behaviors and how it interacts with the operating system. So now we're going to be actually executing the file. So RegShot is a widely used utility, especially when analyzing malware on Windows. I've never used it before, but we're here to learn new stuff. So it works by creating 2 snapshots of the registry. One before you run the malware, and then one after you run the malware. And then you compare the results to identify if any changes were made. Because what malware aims to do is establish persistence, meaning it seeks to run as soon as the device is switched on. Common technique for malware is to add a run key into the registry, which is frequently used to specify which applications are automatically executed when the device is powered on. So what threat actors like to do, or what malware likes to do, is establish persistence within things such as run keys. Windows has registry run keys, and these basically say that anytime that this starts up, if the local machine starts up, or if this user starts up, run this in this registry. Before executing the malicious sample, let's create a snapshot of our registry as it currently is, so we can compare the difference once the sample has been executed. So it's going to say, let's load up RegShot and create a capture of its current registry. So the first thing we're going to do is load up RegShot. So now that we have RegShot open, let's change our output path real quick. Let's put this on our desktop just because it's easy. And then let's take our first shot. So this is our initial snapshot that we're taking over a registry before the malware has been ran. Now we're going to hit first shot and then shot. All right, so now we have taken our initial snapshot of the registry, and then so now we can run our malware. So let's go to File Explorer and then HopHelper, and then let's run this. If you guys notice right here on the left side, these icons just changed to eggs. Somebody looks salty. I think something opened. King Mal here sends his regards. So now we're going to take our second shot so we can compare our initial snapshot to our second snapshot after the malware was run. Now we're going to compare the first snapshot to the second snapshot. So after hitting compare, it opened up this notepad. Now that notepad is open, let's hit Control F on our keyboard to search for the malware. This was called Hop Helper, and let's see what it did. So Hop Helper right here, hard disk. It looks like it's added itself into our registry run key. It's going into so it's in our software, Microsoft Windows current version run, and then Hop Helper. So it's going to run this executable anytime that this computer turns on or this user logs in. And this is how malware establishes its persistence. So the flag asks us which run key was modified to establish persistence. Let's copy this right here and paste it into our flag 3. Awesome. So now we're going to do flag 4, dynamic analysis. Filter the output of ProcMon for TCP operations. What network protocol is hophelper.exe using to communicate? Make sure to have executed hophelper.exe while ProcMon was open and capturing it. So let's go up here for the instructions. It's saying we're going to be using process monitor. ProcMon is one of the sysinternals tools that you can use, and that's what we're going to be using today. So process monitor is used to monitor, investigate how processes are interacting with the Windows operating system. It's a powerful tool that allows us to see exactly what a process is doing. For example, what if it's reading and writing registry keys, searching for files, or creating network connections. So let's close out of these windows and then let's open ProcMon. It's gonna be hard. Right here. I didn't know which one it was. But let's open ProcMon. And now that ProcMon is open, let's rerun our Hop Helper execute or a malware. So now that we have our ProcMon open, let's wait about a minute after we run the malware, and then let's hit the button to stop capturing. So right here, we see a lot of information, and it's going to be hard to just go through. So we're going to be using the filter tool. First thing we're going to do is filter by the process name, and then we're going to look for any type of processes that contain our Hop Helper executable. So this is everything that is being spawned. These are all the processes that are being spawned by the Hop Helper. And then the flag is asking us to look for anything that has a TCP connection and what network protocol is using. So let's also filter by protocol and TCP. Let's filter by TCP. So let's filter by operation. Then contains TCP. Apply, and then OK. And then we have 4 processes right here. TCP connect, send, receive, and disconnect. So if we expand this path right here, we see reach blocker, sandbox, HTTP. So the malware is definitely communicating with somebody else because we have some type of network connections going on right here. But our question was what network protocol is being used, and right here we see HTTP. Enter that. We're all good. Then this says, can you find the web panel that hophelper.exe is communicating with? So this question kind of confused me for a second because obviously it's breach blocker sandbox that it's talking to, but I think it wants us to actually go to the site. So let's open up Google Chrome real quick and type in HTTP // breach blocker sandbox. Then let's see what we get. I guess this is the web panel that it was communicating with. Now that we are done here, it says if you enjoyed today's room, then check out basic static analysis as well as basic dynamic analysis, where you could dive deeper. Well, thank you guys for joining me today. I hope you enjoyed this video. That is the end of our Advent of Cyber 2025 Day 6. Be sure to stay tuned for tomorrow. We're going to be dropping Day 7 as well. Please leave a like, comment, and subscribe if you enjoyed this video. And let me know what you guys want to see down the line.